Now, in this video, we will going to take up one more problem on projections of lines. The problem reads as the top view of a line capital PQ, 75 mm long, measures 50 mm, and the front view measures 60 mm. The end capital P is 30 mm above HP and 15 mm in front of VP. Draw the projections of the line and find its true inclination with HP and VP. Find the distance between the end projectors. So here he says the true length of the line capital PQ is 75 mm. Measure 50 mm in the front view. That means he has given the length of the front view, but he has not given the inclination. He has given the true length, but the inclination of the true length is not given. And he has given the top view, but the top view inclination is not given. But the NP is fixed. NP is 30 mm above HP and 15 mm in front of AP. So, how to proceed with this type of problem? So, to do that, it is like this. When you know that when the top view line is parallel to XY, correspondingly, in the front view, you will going to get the true length. This is the true length line. When the top view line is parallel to XY, which is the top view? PQ1. Do you know that you know the top view length? Yes. What is the top view length? The top view length is 50 mm. So when you look from the top view, you can see that the length of the top view is 50 mm, which is small p q1. But in the front view, what will going to be that length? In the front view, that length is 75 mm. By looking at this drawing, you can see that when you look from the top view, I can see the distance in front of VP, which is that 15 mm. The point P is 15 mm in front of VP. So that is this distance. What we are talking about is capital P to this point. It is this line is in space. So now, when you look from the top view, both capital P and this Q1 are in front of VP by 15 mm. So, as we look from the top view, the distance in front of VP is seen in HP. Where is HP? HP is here. So, you can see that small p and small q1 are in front of VP by 15 mm. So, what we can do is, you will have a length of the top view is 50 mm, and then when you look from the front view, that distance is 75 mm can be seen between these two end projectors. So here, and what is the distance of the point P? The distance of the point P above HP is 30 mm. So when you look from the front view, you can see the distance above HP, which is 30 mm. Where you can see that image can be seen in the front view. That is in VP. Where is VP? VP is here. So that P dash and Q1 dash will going to have the length equals 75. So this distance from here to here, when you look from the front view, you can see that distance between the end projectors is 50 mm. So when the distance between the end projectors is 50 mm, then at that distance you will going to get the 75 mm, and this true length line, when you look from the front view, can be seen in the vertical plane. So you have P dash and you have Q1 dash. So since it is the true length, you will have capital P and capital Q. By getting the length of 75 in the front view, so you got the locus of Q in the front view. So this is how you will be able to analyze in the first step. So how to write this in by using the sketchbook. First, what we will do, we will go to draw an XY line and you mark VP and HP. So as we know, the distance above HP is seen in VP. From XY line, you measure a distance of 30 and draw a horizontal line. Similarly, from XY line, you measure the distance of 15 mm in front of VP, and that will be seen in HP. So from XY line, you measure 15 mm below XY line and draw a horizontal line. And you consider any point from there on this 30 mm line, draw a vertical projector so that it will going to cut these two parallel lines. So you mark this point as P dash and this is capital P, and you mark this point as small p in top view. Now, as we know that as the top view line is parallel to xy, correspondingly in the front view, you are going to get the true length. So, from this projector P, you measure a distance of 50 mm and you mark that point as Q1 in the top view. Then, that P is in front of EP by 15 and Q1 should also be in front of EP by 15 mm. So, from join PQ1 and then from Q1 you draw a vertical projector to the front view. Then with P dash in center, take the radius of 75 by using the compass, cut on this vertical projector so that you will going to get Q1 dash and you mark that point and draw a dashed outline here and since this is the true length line, join between P dash and Q1 dash and indicate that angle as theta, and since it is capital P and Q1, this is the true length line, so obviously this angle will be theta. Now we got the locus of Q in the front view. So this is how you will be able to get the inclination, true inclination with respect to HP, true inclination of the HP in the true inclination with respect to HP. So the true inclination with respect to HP can be seen in the vertical plane. Then, now similarly, I want to get the locus of Q in the top view. How to get the locus of Q in the top view? What is the locus of Q? In the top view, if I want to get the true length, the front view should be parallel to XY. What is the front view line? The front view line is 60 mm. If you want to get the true length in HP, the line should be parallel to HP. If you want to have the line parallel to HP, from where should I look? I should look from the front view. So parallel to HP can be seen in the vertical plane. What is the vertical plane? The point P is 30 mm above HP. Obviously the point Q2 should also be above HP by 30 mm. So this is the line. Capital PQ2 is the line which is in space now. So as you look from the front view, that image will going to be projected onto the vertical plane. P dash is above HP by 30 mm and Q2 dash is also above HP by 30 mm. The distance between P dash and Q2 dash will be equal to 60. So from P dash to Q2 dash will be 60. You draw that. From this vertical plane, you draw a line perpendicular to it. So you know that when the top view line is when the front view line is parallel to XY, correspondingly in the top view, you will going to get the true length. So from P, you measure a distance of 75 and cut an arc on this vertical projector. So you got the true length line in space. When you are looking from the top view, that has been projected onto the horizontal plane. This is small p and here this is small q1, or here this will going to be small q1 here. Now this is the line what you will going to get in the true length line. This will be q2, small q2, because when you look from the top view, since this is q2, so this will be q2, and this is the true length because it is parallel to HP. So since it is parallel to HP, we are getting the true length in HP. This will be capital P and this will be capital Q. So this will going to be the locus of Q. So this is what we will going to get the line in 3D. So how to plot this in 2 dimension? So what we need to do here is with P dash as center, take the distance as 60. You measure the distance as 60 and you mark that point as Q2 dash. Then, as the front view line is parallel to XY, correspondingly in the top view, you will go to get the true length. So, from Q2 dash, you draw a vertical projector to the top view. Then, you know the true length is same both in the front view as well as in the top view. So, from P, by using the compass, with P as center, take the radius of 75, cut an arc on this vertical projector, and you mark that point as Q2, and join between P and Q2 with the dark line bit darker than the XY line, and you mark this angle as phi and draw a dashed outline at Q2, and you mark this as capital P and you mark this as capital Q. This will going to be the locus of Q in the top view. So this is how you will be able to get the true inclination with respect to VP here, and this is the true inclination with respect to HP here. So we know that this is the true length in the front view because the top view line is parallel to XY. Similarly, you know that the true length is in the top view because the front view line is parallel to XY. the P dash is above HP by 30 and the Q2 dash is also above HP by 30, then only the line is parallel to XY in the front view. Similarly here, the line is parallel to VP, because parallel to XY line, because P is in front of VP by 15 and Q1 is also in front of VP by 15, then only the line will be parallel. That PQ1 is line is parallel to XY in the top view. Correspondingly in the front view, you are getting the true length. Then, now we need to get the top view line. How to get the top view line? As we know that the top view is 50 mm here, as the top view line is 50 mm, due to the presence of locus of Q in the top view, that Q1 is not in front of VP by 50, instead the Q1 is in front of VP by this distance, such that without altering the length of the line, the PQ1 should be rotated such that it will going to come and touches the locus of Q in the top view. So how to do that? First we need to do it in space. With P as center, taking the radius of PQ1, you are rotating such that this line, that is Q1 to this line, will move from this point till to the locus of Q here. So this is the one which is the capital P and capital Q is the line in space. So when it is projected from the top view, that image will going to be rotated with P as center, the PQ1 as the radius. You are rotating such that it will going to come and touches the locus of Q in the top view and join P and Q with a dark line. So this will going to be the apparent inclination beta with respect to VP. So this is how you will be able to find the top view inclination of the true length line capital PQ. So how it can be projected here in 2 dimension. So by using the compass with P as center, taking the radius of PQ1, because of the locus of Q present in the top view, with P as center, taking the radius of PQ1 by using the compass, draw an arc such that it will going to cut the locus of Q in the top view. Join P and Q with a dark line. So this they denote that angle as beta, that is the apparent inclination with respect to VP. Similarly, now I want to get the front view. How to get the front view point? So we know where is the front view. The front view is P dash Q2 dash. That is, when you are looking for the front view, this is the line which will going to be the front view. You know that this is the front view line. So if you that is P dash is above HP by 30 and Q2 dash is also above HP by 30. So where is that line in space? That line in space is this line. So with P as center, PQ2 as the radius, you draw an arc, you are rotating that line such that, what happens to that line? Such that this Q2, this line is being rotated in vertical plane. You can see that. I am showing that through my mouse. You can see that it is moving in the same direction such that it will going to come and touches the locus of Q in the front view. That Q can be seen in the front view. So it is seen in the vertical plane. What will going to be that image? That image is P as center, PQ2 as the radius. You are drawing an arc such that this Q2 will going to touches the locus of Q in the front view here. So once you get this is the line actually in space. This is how you will going to get the inclination. If you look from the front view, that is being projected from here till to this point, which is the locus of Q, and since it is the front view line, so you mark that as Q dash. Join P dash Q dash with a dark line. So this is the angle alpha. This will going to be the apparent inclination with respect to HP. So how we will be able to get it in orthographic view? To get it in orthographic view, by using the compass with P dash as center, taking the radius of P dash Q2 dash, you draw an arc such that it will going to touches the locus of Q in the front view, and you mark that point as Q dash and join P dash Q dash with a dark line, and you mark that angle as alpha. Then we need to find out the distance between the end projectors. What is the distance between the end projectors? The distance between the end projectors is the line joined between the front view line and the top view line of the end projectors. That means the distance between, the horizontal distance between P dash to P and Q dash to Q. So what is the distance? That D is equal to question mark. So D will be equal to 22 mm when you are doing it in manual. And by using the protractor, you measure the angle, apparent inclination alpha, which is 69 degree, and then theta will be true inclination with respect to HP. That will be 48.19, it means 48 degrees, and with PI center you measure the true inclination with respect to VP, which is 5, which is 37 degree, and then with respect to apparent inclination with respect to VP is beta, which is 64 degree. So this is how you will be able to find the answers by doing manual sketching. How do I know that my problem is right? When you join between Q dash and Q, both will going to lie on the same line. That is point number 1. You know this is the front view because the top view line is inclined. You know the true length in this is the true length in VP. That means it is the true length in the front view because the corresponding top view is parallel to XY. You know the true length in the top view because the corresponding front view is parallel to XY. So this is how you can analyze it and you can say that my drawing is right. Finally, when you are doing all these things, both Q dash and Q must lie on the same line. Otherwise, if it doesn't fall on the same line, then we have committed some mistake somewhere. So this is how you will be able to analyze and solve the problem on the projections of line when the front view, top view and true lengths are given without knowing the inclinations. You will be able to find the both apparent and true inclination with respect to both HP and VP. Thank you.